Lesson Term 6. A circle is defined as all the points equidistant from a given point, called the center. A diameter is defined as a segment with both endpoints on the circle and contains the center. So an example of a diameter would be the blue, but I have to make sure that when I'm drawing my diameter that it goes through the center. We'll have a word for something like this later on. A radius is a segment with one endpoint at the center and one endpoint on the edge of the circle. In other words, it's half of a diameter. Congruent circles are two circles with the same radii. And the last vocab word is a central angle. A central angle is an angle whose vertex is at the center of a circle. So this would give us our central angle. Now let's talk about parts of those angles or arcs. An arc is a part of a circle. So down in the picture below, this red portion is called an arc and the blue portion is an arc. The red is called a minor arc because it's less than 180, and the blue is called a major arc because it's more than 180. So a semicircle is an arc that is half of a circle, which is equal to 180 degrees. A whole entire circle would be 360. So a minor arc is anything that's less than that 180, and a major arc has to be more than 180. So then notice our labels. If I label a major arc, I'm going to have 3 vertices in the name. If it's a minor arc, it's just going to have 2. So the only way to get from R to S is from here to here, but major arc STR could also be named RTS. So there are a couple different ways to name those major and minor arcs. Arc RS could also be called SR. And then notice how it has the arc symbol over the top. It's not a bar like on a segment, it's an actual arc. So here are some vocabulary questions. Looking at circle O. This is O, so the center is called O, so it is called circle O. So this is a symbol for a circle. What are the minor arcs of circle O? So we're looking for arcs that are less than 180. So I'm noticing 2, AD and CE. A couple different ways that I can notate that. I usually end up doing alphabetic or whichever one I see first. So an alternate answer could be DA and EC. Part B, what are the semicircles of circle O? A semicircle is 180 degrees. So I could go here and do a semicircle. I could go here and do a semicircle. This would be a semicircle. And this would be a semicircle. So I believe I have 4 different answers in there. I just named 2. So the reason I know that they're semicircles is because this is a straight line. It is a diameter. So if I get an arc that intersects on a diameter, it is going to be a semicircle. So that could be called DC or CD, AE or EA. So written out, this is the blue arc and this is the green arc. So you'd also have CD, which would be the yellow arc, and EA, which would be the yellow arc. So CD is actually the pink arc, excuse me. So then if I look at my endpoints, notice that blue and pink are the same, and green and yellow are the same. So I wouldn't want to name them twice. So my answers are arc DC and arc AE. Question C. What are the major arcs of circle O that contain point A? The first arc that I think of is ACD. I only need to name 3 coordinates in that arc. I could also call that AED and skip point C. Another major arc that I see is arc DAE, or I could call it DCE. Remember, a major arc is greater than 180 degrees. Another major arc that I noticed would be arc ABC or AEC. And another major arc I found was CAE. So when I'm checking to see if I've repeated, I'm looking at these endpoints, AD, DE, AC, CE, just to make sure that I haven't repeated any. Why don't you try the next slide, pause the video while you think about what your answers are. Push play when you're ready to check those answers. The minor arcs are going to be RS, SP, PQ, and QR. A semicircle would have to intercept the diameter. So I'm looking at RP. And because it wasn't really defined, you could call that RPS or PR or PR or PSR. Those would all be the same arc. To make sure that you do the red part of the arc or the pink part of the arc instead of the reverse side, you would probably want to include that point S. So I would throw this out and that answer out. To do the other side of the semicircle, you would want to include P, Q, and R. Here are some major arcs. R, P, Q, SPR would be the same thing as SQR in yellow. Then moving on to the green, PQS would be a major arc. And then I see another one, QRS. So if I pay attention to my directions, it says, what are the major arcs of circle A that contain point Q? So my pink, yellow, and green are major arcs, but we want to focus on the ones that just contain Q. So I think we need to throw out the yellow arc, and the others are good. Looking up at the circle, I drew an arc in black that would also work. That would be called RQS. And we'll stop there on that question. Let's get into some more vocabulary. We've been talking about arc. Now we're going to move on to arc measure. Arc measure is the measure of an arc, and what it is equal to is the measure of its corresponding central angle. So if the central angle is 50 degrees, then the measure of this corresponding arc would be 50 degrees. And here's what that notation would look like. The measure of arc RT is equal to 50 degrees. So remember, a semicircle is exactly 180 degrees, minor arcs are less than 180, and major arcs are more than 180. Find the measure of each arc in circle R. US is a radius in the circle. Question number 4, arc UT. Remember, an arc is the same as its central angle, so UT is 114. Number 5, ST is the blue. Well, it looks like SU is the diameter, so the supplement of 114 is 66. Which gives our arc a measure of 66. Going across to number 6, arc SV, highlighted in blue. Well, remember that this purple is a diameter, so if this angle is 90 degrees, that makes this central angle also 90 degrees. So its arc is 90. Arc VST contains 90 degrees and 66 degrees for a total of 156. Going on to question number 11. Notice these are not numbered correctly. USV tells me that I have to go in this order, to hit U, and then S, and then V last. So I'm thinking an entire circle is 360, So if I subtract how much is not covered, which would be the 90, I can get my answer of 270. So subtracting in this case was quicker than doing 114 plus 66 plus 90 for me. Number 12, UTS. UTS hits a diameter, so its measure better be 180. Arc UVT goes on the other side, so I hit U first, then V, then T. So it looks like I am enveloping that 180 degrees plus 66 for a total of 246. Otherwise, you could do 360 minus 114. And that would also give you your 246. The arc addition postulate. All this says is that if you add two arcs together, let's say that this arc is X and this arc is Y, the measure of arc ABC would be equal to X plus Y. So we can add those together. So looking at question A, what is the measure of the arc BC? Well, BC is from here to here, so its arc is 32 degrees. Then if we go B to D, well, I'm going to extend to here, so we're going to do 32 plus, you got it, 58 for 90. The next arc is ABC, which looks like it hits a diameter, so you got it, the answer is 180. The next arc is the pink arc, AB. AB is almost that whole semicircle. So if we do the semicircle minus that 32, we will get our answer, which would be 148. So 180 minus 32 for 148. Try the slide on your own. Pause the video till you're ready to see the answers. Part A, PR is the same as its central angle, 77. Looking ahead at my picture, I can kind of tell that PS is a diameter. So the supplement of 77 is 103. Same thing goes with 28. The supplement with 28 is 152. So then from R to S is 103, the same as its central angle. PRQ would be going from P to R, from R to S, and from S to Q. So we could just do 360 minus 152. The remaining answer would be 208. PQR is very similar to that, such that we can do 360 minus 77 to get our ending answer of 283. This concludes part 1 of lesson 10.6.